Today we're looking at Chapter 2 again, the basic concepts of set theory. We've already talked about Section 1, which is symbols and terminology, and we're going to look at Venn diagrams and subsets today. So Venn diagrams is one of the topics that we're going to be talking about. Complements are another topic that we're going to talk about. Subsets of a set, proper subsets, counting subsets. So our first information about Venn diagrams is the concept of a universal set, denoted by the symbol capital U. In set theory, the universal set is the set of all possible objects or all possible elements in the set. So Venn diagrams were developed by John Venn in the 1900s, late 1800s. In these diagrams, the universal set is always represented by a rectangle, and then the other sets of interest within the set are used as circular regions, and these regions can overlap, and that's how you determine whether elements are in two different sets. So the rectangle represents the universal set U, while the circular part represents the set A. So for example, the set U could be all real numbers, and A could be counting numbers. So A is a part of the set, A is a part of the universal set, but it is also its own set if you think of it separately. So again, U could be all the real numbers, and A could be all of the integers. Or U could be all of the integers, and A could be whole numbers, because again, whole numbers are a part of integers. So the colored region inside of U, but that is outside of the circle, is called A prime, and that is called the complement of A. In other words, A prime is all of the elements of the set that are not in A. So for any set A within the universal set, the complement A prime is all of the elements that are not in A but are in the universal set. So if you'll notice, our set builder notation here says the set of X such that X is an element of the universal set and X is not an element of A. And that's our set builder notation. That's what A prime is. So let's use the following information to find the complements. If U is the set of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and A is the set of numbers 1, 3, 5, and 7, then if I wanted to find A prime, I would take the universal set and I would eliminate 1, 3, 5, and 7. And whatever I'm left over with, those are A prime. So if I eliminate 1, 3, 5, 7, I'm left with 2, 4, 6, 8, 9, and 10. Those would be A prime. Same thing for B prime. If I take out the elements 2, 4, 6, 8, and 10 from the universal set, the elements that are left are B prime. So that would be 1, 3, 5, 7, and 9. U prime means take all of the elements of the universal set and eliminate them. So that would be the null set. And then the prime, the complement of the null set, would be the universal set. So those are two notations that you may need to be familiar with. So set A is a subset of B if every element of A is also an element of B. And the symbol for subset is the C with the line underneath. So in this case, that means every element of A is also an element of B, but that could mean that there are elements in B that are not in A. So let's look at this. Is A a subset of B? So set A contains the elements A, B, C, and set 2 contains the elements A, C, and D. So A, the first set, is not a subset of the second one because there are elements in A, or in the first one, that are not in the second one. But on the second example, B, 1, 2, and 4 are part of the other subset. Now 3 is not, but it contains 3 of the elements that are in the second set. So in this example, the first set A, ABC, is not a subset of ACD. But the elements in the set 1, 2, and 4 are a subset of the set 1, 2, 3, 4. Suppose that A and B are both sets. Then A is equal to B if A is a subset of B and B is a subset of A. So we talked earlier about equality meaning that all of the elements in A are also in B. Well, that's what subset means. So subset means that all of the elements in A are also in B. But looking at the converse of that, in other words, switching it, B is also a subset of A. So that means they both have the same number of elements and they both have the same elements. So a proper subset is when A is a subset of B, but A and B are not equal. So the symbol for the symbol for proper subset is the C without the line underneath. So let's look at this one. Let's see if these sets are subsets of each other, proper subsets of each other, or both, which could happen. So remember, to be a proper subset, not only do they have to have the same elements, but they also they cannot be equal to each other. So on example A, B, and C are elements of the set A, B, C, and D. So A, B, and C is a subset of A, B, C, D. Since A, B, C is not equal to A, B, C, D, then it is also a proper subset. So example A is both. It is a subset and it is a proper subset. Example B, the numbers 1, 2, 3, 4 are in the set 1, 2, 3, 4. So the first example, 1, 2, 3, 4, is a subset of 1, 2, 3, 4. But since the first set is equal to the second set, then it is not considered to be proper. So example A is both. It is a subset and a proper subset. Because the size of the sets is not equal, because they do not have the exact same elements, they are considered proper ones. And the second example, 1, 2, 3, 4, and 1, 2, 3, 4, are only subsets. They are not proper subsets. So one way to figure out all of our subsets is to do what we call a tree diagram. And what you'll see in the figure below is that if I have two numbers, A and B, and I'm trying to figure out all the possible sets of A and B, so my set could contain A, or it might not contain A. If it contains A, then it could contain B, or it might not contain B. So if it contained A and it contained B, then my subset would be the set A, comma B. If it contained A, but it did not contain B, then my subset is just the element A. If it contains if it does not contain A and it does contain B, then it is a subset with element B. If it does not contain A and it does not contain B, then it is the null set. Whenever we're counting subsets, we always have to remember to count the null set as one of the subsets. So in this example, there are two numbers and there are 4 subsets. So let's look at some more. With the null set, there's only one subset, and that is a subset of null. With one number in the element, or one number in the set, there are 2 subsets, because remember, null set always counts as 1. If there are 2 numbers in the original set, then there are 4 subsets. We just saw an example where we came up with all 4 of them. If there are 3 elements in the set, then there are 8 subsets. So how many elements, if there are 4 elements in the set, how many subsets do you think there will be? So if we look at the pattern here, when it was 1, there were 2. And you'll notice that the next number of subsets is a multiple of 2. And the next elements in the subset is 2 times that. So what we end up doing is we end up taking the number of items, the number of elements in the original set, and raising it to the second power. So the number of elements in this set should be 4 raised to the second power, which is 16. So the number of elements in the third example, or the fourth example, would be 16, the number of subsets. So here's that list of subsets for you. What I did, I took down the 1, 2, 3, and I broke it down more. So if 1 is a subset, it could have 2 in it, and it could have 3 in it, so that would be 1, 2, 3. If 1 is in it, it might not have 2 in it, but it might have 3 in it, so that would be 1 and 3. So these are all the possible subsets for 3-element subsets. So 3-element sets, 3 to the second power would be 9. I'm sorry, I said that wrong. 2 to the third power is 8, and you'll notice that the number of elements that we have in our set is 8. So the number of subsets in a set with n elements is 2 to the n power. So the number of proper subsets of a set with n elements is 2 to the n power minus 1. And the reason for that, the reason is that proper subsets are always going to have 1 less, because you don't have that, you can't have that equality with the sets. There's always going to be 1 less element. So let's find the number of subsets and the number of proper subsets of the set M-A-T-H-Y. Since there are 5 elements in the set, then the number of subsets that we can make up of the set would be 2 to the 5th power, which is 32. The number of proper subsets would be 32 minus 1, which is 31. I hope this helps. You might want to go ahead now and look at the homework assigned in My Math Lab for section 2.2. Let me know if you have any problems, and I will talk to you later. Have a good day.